Hello everyone and welcome. In this lecture we will see the Cramer's rule, which is an easy method. So this method requires just that matrix A, when we have the linear system AX equals B, it requires that this matrix A to be a square matrix. That means the number of equations and the number of unknowns of this linear system are equals, and also it requires that the determinant of A to be different from 0. So once with these two, or as the determinant is just for the square matrix, so once the determinant of A is different from 0, we can use the Cramer's rule to get the solution of this linear system. And to get it, so each value or each solution x1, x2, xn. So x1, for example, will be the determinant of the matrix B1 here, or determinant of A. The matrix B1 here is a matrix A, but when we replace the column 1 here, for example, the first column, by the matrix, by the vector column vector B. And to get x2 here, we will use the determinant of B2. And to get B2 here, it will be the matrix A, but we replace the second column with the column vector B, and so on. So for example, xn will replace the matrix, the nth column here in the matrix A by the column vector B to get the matrix Bn, and then xn from this expression. We'll see it an example, and you will see that it is an easy method. So here is the same example that we have seen before. So first we must compute the determinant of A. So the determinant of A is equals 2, 4, minus 6, and minus 1, 2, minus 1, and 3, 1, 2. And as it is 3 by 3, so we can compute it by replacing this, or by putting these two columns here. So 2, 4, minus 6, and minus 1, 2, minus 1. And this equals, so multiply this element here will be 2 times 2 times 2, which is 8, and minus 1 times 1 times minus 6, which is plus 6, and 3 times 4 times minus 1, which is minus 12. And this minus, well, the product of these elements, so 3 times 2 times minus 6, which is here 3 times 2 is 6, so minus 36, and 2 times 1 times minus 1, which is minus 2, and minus 1 times 4 times 2, which is minus 8. So this equals 8 plus 6 minus 12 is 14 minus 12, which is 2, and here minus, here 36, here minus 36 minus 2 minus 8, so this is 10, 10 minus 36 is minus 46, here plus, so it will be plus 46, and this equals 48. So now the determinant of A is 48. And now we want to get the values for x1, which is, so we know that x1 is equals determinant of B1 over the determinant of A, and this B1 here is when we replace this column by the column vector B. So when we replace this column here by this vector, and the same for x2, for example, is it will be just B2 here, and the B2 here will be replacing this column by this column, and the same also for B3, x3, for example, it will be B3, and we replace, to get B3, we replace this column by the column vector B. First we will start by determinant of B1, so it equals, here we will replace this column here by b, so it will be 1 2 3, so the vector b, and we will use these two columns as they are, so minus 1 2 minus 1 2 and minus 1 and 3 1 2. So we just replace this column here by the column vector b. And to compute the determinant of 3 by 3, we will put these two columns here, 1 2 3 minus 1 2 minus 1, and this equals 1 times 2 times 2, which is 4, and minus 1 times 1 times 3, which is minus 3, and 3 times 2 times minus 1, which is minus 6, and this minus the product of these elements, so 3 times 2 times 3, which is 3 times, so 9, so 18, and here 1 minus 1, 1 times 1 times minus 1, which is minus 1, and minus 1 times 2 is minus 4. So here is minus 9 plus 4 minus 5, and here is 18 minus 5 is 13, so minus 13, so this equals minus 18. And also the determinant of b, so if I delete this space here, so this is equals 48, and this is minus 18, so this is also minus 18, and we'll benefit from this space. So now is the determinant of b2. b2 is just this. We will write this column, so 2 4 minus 6, but we will replace the second column here by this vector column, so it will be 1 2 and 3, and here 3 1 2. We just change the second column here by this column here, so we will put these two columns here, 2 4 minus 6 and 1 and 1 2 3, and this equals, so 2 times 2 times 2, which is 8, 1 times minus 6, and 3 times 4 times 3, so this is 3 times 3 9 times 4 is 36, so plus 36, minus all these elements are 3 times 2 times minus 6 is, yeah, 6 minus, so minus 36, and 2 times 1 times 3, which is 6, so plus 6, and 1 times 4 times 2, which is 8, so plus 8. So here we have 8 and here minus 8, so this 8 will cancel with this 8, and this here it will be 30, and here minus 36 plus 6 will be minus 30, but here we have minus, so it will be plus 30, so equals 60. And the determinant of b3 equals, here we have 2 4, the same here, 2 4 minus 6, and the same here, minus 1 2 minus 1, minus 1 2 minus 1, but we will replace this column here by the column vector b, so it will be 1 2 3 here, and when we put these columns here, 2 4 minus 6 and minus 1 2 minus 1, this will be equals, so if I write them here, so it will be, it equals 2 times 2 times 3, which is 4 times 3 12, and minus 1 times 2 times minus 6, so minus 1 times, so plus 6 times 2 is 12 also, and here 1 times 4 times minus 1, so minus 4, and this minus, these ones here are minus 2 times minus 6 minus 12, and here 2 times 2 times minus 1 is minus 4, and here minus 1 times 4 times 3 minus 12, So here this 4 will cancel with this 4, because here minus and minus here plus, so minus 4 here, and this will be 24, and here will be minus 12 minus 12 minus 24, but here plus, it will be plus 24, and this equals 48. So now we get all the determinant, and just we will replace them here. So x1 is equal to determinant of b1 over determinant of a. So this is minus 18 over 48, and this equals, when we divide here by 6, it will be minus 3, and here it will be 8, so minus 3 over 8. And x2 is just determinant of b2 here over determinant of a, and this equals determinant of b2 here is 16 over 48. And when we divide by 12, so 16 divided by 12 is 5, and 48 divided by 12 also is 4. And x3 is equals determinant of b3 over determinant of a, and his determinant of b3 is 48, so 48 over determinant of a is 48, and this equals 1. And these are the same solutions that we have get from the other methods.